Hey everyone, Miss Barber here for lesson 1.3 in Algebra 2, a lesson on square roots. So what you should do first before you do anything, pause the video. Can you come up with a list of perfect squares from 1 to 200? And if you're thinking, I don't even know where to start, think about this. If I take 1 and I square it, what do you get? Well, you get 1. I'll just make a whole line here. All right, well, if you get 2 and you square it, what do you get? Well, that's 4. 3 squared, 3 times 3, that's 9. So what you need to do is go ahead and list out all the perfect squares, which would be this bottom row here, that you can come up with from 1 to 200. It goes on infinitely, so it's going to go on way past 200, but probably for our purposes in class, 200 will be sufficient. So go ahead, pause the video and do that. And if you want to check your work against the key to make sure you've got them all, you're more than welcome to do that. The reason we're going to need these perfect squares is in order to simplify square roots. So in order to simplify square roots, there's 2 properties we're going to use. The product property. The product property just states that if I have 2 things inside a square root, I can separate them via multiplication. This is going to be very helpful when we simplify because we're going to use this property to pull out perfect squares. Quotient property is the same thing. If I have 1 fraction underneath the square root, it's the same thing as the separation of 2. Sometimes they'll be separated and you're going to need to put them back together. So we're going to kind of go back and forth using both these properties to help us simplify square roots. So here are some examples that they gave you down here. So the square root of 72. If you put the square root of 72 in your calculator, you're not going to get a whole number. It's an irrational number. So it's not a perfect square. Instead, we have to find the largest perfect square that's going to go into 72 in order to simplify. Well, the largest perfect square that goes into 72 is 36. So I can separate 72 as 36 times 2. The square root of 36 is 6. That's a perfect square. And then the root 2, again, that's an irrational number. It's not a perfect square, so we're going to leave it under the square root sign. For a fractional, the square root of 64 over 25, well, I look here and I say, well, I know the square root 64 is a perfect square and 25 is a perfect square. So instead, I'm going to separate them into 2 separate fractions. 2 separate numerator and denominator square roots. And I can take the square root of both individually to get my fractional answer. You might also have examples like this, root 24 times root 6, where neither of these numbers, 24 or 6, are perfect squares. So instead, we're going to multiply them together like it asks to get 144, which happened to be a perfect square, 12. Or we have 2 square roots in my fraction, root 125 and root 5. Neither of those are perfect squares, but when I combine them to 1 fraction, I can simplify. 125 divided by 5 is 25, and then that's a perfect square. So you might need to move square roots around, multiply, divide, in order to simplify in the easiest way possible. All right, example 1, they want you to estimate the square root to the nearest tenth. So you could obviously always just use your calculator to find these, but it is helpful in maybe a multiple choice SAT non-calculator scenario to know where these would fall. Well, the square root of 78, I know that a perfect square that's larger than 78 would be 81. So I can say that I know the square root of 81 will be bigger than it. And then it's also going to be larger than the square root of 64. So those are my 2 perfect squares that fit on either side of 78. The square root of 64 is 8, and the square root of 81 is 9. So my number here is going to be somewhere between 8 and 9. 78 is much closer to 81 than it is to 64. So I know it's going to be 8 point something closer to 9. And it turns out that it's 8.8. So much closer to 9 than 8 because 78 is closer to 81. So number 2, we can set up just like that, not trying to confuse the negative out in front. So negative 57, a number, the biggest square root next to it would be negative root 49. Remember, the more negative a number is, the lower it is on the number line. And then smaller than negative 57 for a perfect square root would be negative root 64. Well, the square root of negative square root 64 would be negative 8. And then this would be negative 7. Well, 57 is kind of right between 49 and 64, so it actually turns out that this number here is negative 7.5, so right in the smack dab middle. So pause the video, see if you can come up with a square root, estimate for a decimal for root 39. So what's the largest perfect squares that are it's close to on either side? Now to simplify. So we saw some examples of simplification up there. So to simplify the square root of 243 for number 4, you want to find the largest perfect square that goes into 243. The largest perfect square is 81. So I'm going to rewrite this as 81 times 3, because 81 times 3 is 243. If you want, you could even separate these two using the product rule. So I have the square root of 81 times the square root of 3. The square root of 81 is 9. I took the square root, so the square root goes away. The square root of 3 is a decimal. I can't take the square root of it. So that's going to be my final answer, 9 root 3. Number 5, we have a fraction here, root 90 over root 40. I don't know, 90 nor 40, they're not perfect squares. Because they're both bigger numbers, I think it's going to be easier if I put them back together again into one fraction using the quotient property. So I'm going to do 90 divided by 40 all in the same square root. Well, 90 divided by 40 is the same thing as 9 over 4, simplifying that fraction. Well, now 9 and 4 are both things I know how to take the square root of, so I'm going to re-separate them out. The square root of 9 is 3, and the square root of 4 is 2. So that's how I get my answer of 3/2. We'll try one more together, and then you're on your own for numbers 7, 8, and 9. So number 6, again, I have two square roots. I'm multiplying them together. I don't know the square root of either. They're not perfect squares, so I'm going to multiply them together. So I'm going to do 42 times 3. Well, 42 times 3 is 126. Again, that's not a perfect square, but I do know that 9 goes into 126, and it's going to be 9 times 14. Well, the square root of 9 is 3, and I don't know what the square root of 14 is. It's not a perfect square, so it's going to stay stuck inside the square root, and that will be my final answer. So pause the video and try these next ones. You might notice, and especially in 7 and 9, that negatives are going to pop up. The negatives are fine. They'll just stay out in front. You cannot take the square root of a negative number, but notice the negatives on outside of the square root for both 7 and 9. So that should not impact your ability to take the square root of those numbers. So pause and check your answer against the key. All right, let's move on to example 3, rationalizing the denominator. So there's a rule in math where you cannot have a square root in the denominator for your final answer. So to get rid of it, you multiply both the numerator and the denominator by that denominator square root. The reason we do this is, looking at the denominator here, root 5 times root 5 is the exact same thing as the square root of 25, which is just plain old 5. A square root times a square root undoes the square root if it's the same number, and you're going to get 5 in the denominator. Now there's no more square root. We rationalized it. We're good to go. The numerator is just going to be 6 times root 5. You're not allowed to multiply those numbers together. One's inside the square root, one is not. So that will be your final answer, 6 root 5 over 5. So number 11, we're going to do the same thing. Again, our denominator of root 3, we cannot have in our final answer. So we're going to multiply by root 3 over root 3. Your denominator will just end up being 3. The square roots and the squaring undo each other. Your numerator is going to be negative 3 root 15 times 3, which is 45. The square root of 45 is definitely not simplified, so we're going to actually have to go ahead and do that. So off to the side, you're going to want to do square root of 45. Well, the square root of 45, the largest perfect square that goes into it is 9 times 5. Square root of 9 is 3, so it will be 3 root 5. So I know that this square root 45 here is going to be 3 root 5. So what's highlighted in yellow is going to simplify. Looking at my fraction, my answer here, I see I have a negative 3 and a 3. Well, those are going to cancel each other out and become 1s. So my final answer is just going to be a negative left over, and then my root 45, which has been simplified, to 3 root 5. So that's going to be your final simplified answer. Pause the video and try number 12 on your own. All right, last thing here is like and unlike radicals. Just like with combining like terms, they have to have the same variables with the same exponents. Like radicals have to have the same number underneath the radical, which is called the radicand. You cannot add or subtract radicals if they don't have the same number under the square root. So looking here at number 13, we have 7 root 5 minus 10 root 5. This is the exact same. We have root 5 for both. This is the same thing as saying like 7x minus 10x. You just subtract the coefficients. Well, 7 minus 10 is negative 3. Now, we don't have x's here. We have root 5s. But it works the same as with square roots. Let's try the next one. We have 12 root 3 plus 3 root 12. Well, root 12 and root 3 are not the same. So as of right now, we can't add them together. However, if I simplify root 12, I probably can. So let's simplify root 12 off to the side here. Root 12 is the same thing as 4 times 3. Well, the square root of 4 is 2, so root 12 simplifies to 2 root 3. So I can substitute that back in here. So I'm going to have my 12 root 3, my first problem, first part of my expression, plus 3, this 3 here, times 2 root 3. 2 times 3 is 6, so I get 6 root 3 and 12 root 3. Well, 12 root 3 plus 6 root 3 will give me 18 root 3 as my final answer. So we got the same radical for both, so we could add them together. Pause the video, try number 15. You should be able to get the same radical when you simplify both the root 50 and the root 32. Last problem, number 16. A building has a mural painted on the outside wall. The mural is a square, so let's go ahead and draw a square. Remember, square, all sides are the same, so I'll label both sides X. The total area, so the whole inside, is 14,400 square feet. What's the width? Well, the width is going to be whatever X is. Remember, area is base times height, or length times width. Well, in this case, the length and the width are the same, so it's going to be X squared, X times X equals 14,400. To undo a square, you square root. So if I take the square root of both sides, I'm just going to have to take the square root of 14,400. Turns out that's a perfect square. It's 120. So the width which is also the same thing as the height of my mural because it's a square, will be 120 feet. That's it for square